Okay, this video we're going to review scientific notation or standard form. On the IB test, you're going to see it written like this, where they'll say the number is going to be written as a times 10 to the power of k, where a is greater than or equal to, or 1 is less than or equal to a, and a is less than 10. So a is between 1 and 10, but it's not going to be equal to 10, it's going to be greater than or equal to 1. And k is going to be a positive or negative integer or 0. So the reason why we use scientific notation is in three cases. One is it's very convenient to represent a really big number. For example, the number Google is 1 with 100 zeros. So how would you write that? You can either write that 1 with 100 zeros, and we can't even fit them across this page, or we're going to write it in standard form where a is going to be 1, and it's going to be 10 to the power of 100, so that's 100 zeros. So that's a very small, short form to write the number Google. It's also convenient for writing very small numbers. So here we have 0.00000 all the way to here, 4566880, and the way we write that in standard form is here. Okay, so we take the part that's significant figures and we put it here, and we put a decimal point after the first number, and since these last two zeros are also significant, we put those here. All the significant figures need to stay in the value for a, and then we just figure out how many times we need to move the decimal point over to get to between the 4 and the 5, and that's going to be negative 30. Okay, so the other case, besides for very big numbers and very small numbers, for just regular size numbers, we can use scientific notation to explicitly show how many significant figures are in the number. For example, if we have the number 54,322,000, normally if we're going to judge how many significant figures are here, we're going to have to say that there's 5. Okay, because these last three zeros, they're placeholders, so we're going to say that they're not significant. But let's say that you actually measured a couple of these zeros. Okay, so if you measured those zeros, we want to keep them as significant figures, but there's no way to show that here. Okay, if you measured all three zeros, maybe you could write it like this and put a period at the end. But what if you just measured like 2 of the zeros? You didn't measure 3 of the zeros, you measured just 2. So in that case, what you would do is you would write it in scientific notation or standard form, and you would write 5.432200. You would put those 2 measured zeros there, times 10 to the 7th. So that would explicitly show that of those 3 zeros, 2 were measured and 1 was not. Okay, so that's another case where standard form is has an advantage over regular numbers. Okay, so here's some examples of what is improper standard form. Okay, so for example, here we have 0.9 is not between 1 and 10, right? So we wouldn't write it like that. We would write 9 times 10 to the, and I think it would be 10 to the 4th, right? Okay, so 9 to the 10 to the 4th would be 9 with 4 zeros. We're just checking to see if I did this right. 0.9 times 10 to the 5 would be 0.9, and then 1, 2, 3, 4, 5. So that would be 9 with 4 zeros. So yes, so this is equal to this. So this is the right way to write that. Okay. What about this? 10.3 times 10 to the 6. 10.3 is not between 1 and 10. So this needs to also be changed. Let's say to 1.03 times 10 to the something. It would be 10 to the 7th, I think. Okay, so let's test that out. 1.03, we're going to move it 7 times. 4, 5, 6, 7. So there's 5 zeros after that. Okay. So, and then if we test that, 10.3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5 zeros. Okay, so 10,300,000, 10,300,000. Okay, so that's right. And this is also not standard form because the exponent is not an integer. Okay, and this would be a big mess, so I'm not going to show you what the right way to write that is. But okay, so these are all 3 examples of what not to do for standard form, because you need to respect the rules here at the top. Okay, a needs to be 1 is less than or equal to a is greater than 10. Okay, and k has to be an integer.